question. A famous experiment that can detect the presence of carbon dioxide gas is known as the lime water experiment. Carbon dioxide gas reacts with clear calcium hydroxide solution to precipitate calcium carbonate, causing the solution to turn a milky color. The question is asking, using the thermodynamic data provided, calculate the standard Gibbs Free Energy of the reaction at 300 Kelvin. So someone already kindly calculated change in enthalpy and change in entropy. So now we're going to use the equation delta G naught reaction equals delta H naught minus temperature delta S naught. And so this superscript naught, this little circle, means that the substances are at standard state. So standard state, what does that mean? For pure liquids and solids, that means they're under the pressure of 1 atmosphere. For pure gas, it means it has a pressure of 1 atmosphere. And for solution, it means there's 1 molar of solution. So that's just what these knots here indicate. The substances are at standard state. So let's just plug in some values that were calculated for us. Delta H naught was negative 96.42 kilojoules per mole. The temperature was given to us right here. So we're going to subtract 300 Kelvin times delta S naught. So our change in standard enthalpy right here, change in standard entropy right here is in joules per mole Kelvin, because that's what our table for S entropy was in. But what we needed in is the same units that we have here, because in the question it does ask for kilojoules per mole. So the way we do that, we just put one kilojoule there, which will give us negative 0.134 kilojoules per mole K. Okay, so then we put that in, 4 kilojoules per mole K. It gives us a change in standard Gibbs Free Energy of the reaction of negative 56.1 kilojoules per mole. 366 is what we're using in this one. So what does this delta G tell us? Delta G can tell us a lot. So here's what delta G can tell us. If delta G is less than 0, so negative, it means that it's thermodynamically favorable. So the reaction is going to move to the right. There's good products are going to be made. Okay? In other words, it's spontaneous in the forward direction. If delta G is greater than 0, it means it's thermodynamically unfavorable in this forward direction. The reaction's actually moving to the left, which means it's going towards the reactants, and therefore forward, not spontaneous. And if delta G were to equal 0, it means that the reaction is at equilibrium, which means that the concentration of products and reactants is remaining constant. It's not changing. And so we look at our delta G naught reaction, and it's negative, less than 0. Therefore, our reaction is spontaneous in the forward.